Hello everybody, this is lesson 2, similar polygons. So we're going to be talking about congruent polygons, and we're also going to be talking about corresponding angles and sides. So to define similar polygons, first let's talk about what congruent polygons are. So from previous grades, you would have talked about congruent polygons, which have the exact same size and shape. Congruent polygons are a perfect match because all the angles are the same, and all the corresponding sides are the same. And when we talk about corresponding sides and corresponding angles, let's take a look at this example here. You have to be careful that you're talking about the same angles. For example, angle A is this corner and it has the value of 45 degrees. Angle D is also here and it has this angle of 45 degrees. So you can say that angle A is congruent with angle D. And you can go around each triangle and you can look. Angle C is 95 degrees, angle F is 95 degrees, so angle C and angle F are congruent. Angle B is 40 degrees and angle E is 40 degrees, so angle B is congruent with angle E. What you cannot do is say something like angle A is congruent with angle E, because angle A is 45 degrees and angle E is 40 degrees, so they would not be congruent. The same thing goes with sides. Okay, AC is 145 and DF is 145. So AC, or you could say CA, is congruent with FD. CB is 161 and FE is 161, so BC and EF are congruent. Now when you have two vertices that are joined, you just use the letters A and B. If you have an angle, use the angle symbol, angle A. That way you know whether you're talking about angle A or vertex A. And the last one I didn't go through was side DE is congruent with side AB. Now, if all the angles and all the sides are congruent, then we can make a statement like this. Triangle ABC is congruent to triangle DEF. So, when you're talking about triangles, you need to include the triangle symbol if you're talking about the entire triangle, include the angle symbol if you're talking about an angle, and have two capital letters that indicate a line segment from between A and B, or E and F or D and F, or whichever two vertices you're using. Similar polygons have the same shape, but not the same size. So these are a little bit different. They're not congruent, but they're similar. So they have the same angle, but not the same side lengths. The mathematical symbol for similar is this little line here. And if I exaggerate it, it kind of looks like a little wave. Okay, so that means similar. So these two following quadrilaterals are indeed similar. You'll notice that all the corresponding angles are the same. Okay, so let's go through them. Angle A, you got to find angle A first, and that's going to be 105 degrees. And the corresponding angle to that is angle W, which is also 105 degrees. Angle B is 45, and angle X is 45 degrees. Angle C is 90, and angle Y is 90. Angle D is 120, and angle Z is also 120. So all of those sides are corresponding. The angles are corresponding. Now let's go into the side lengths. So the side length AB is 11. And where's the corresponding side to AB? Well, it's in the same position, and it's going to be 110. And it's WX. Now let's take a look at the next one. We're going to do BC. So BC is 15. And the corresponding side to BC is XY. And that's 150. Side CD is 4, and side YZ is 40. DA is 8, and ZW is 80. Now there's no units here, okay? Sometimes you might see that it's centimeters or inches or whatever, but in this case there's no units. So we're just going to use the numbers. So let's figure out the ratios. So WX over AB, you're going to take the measure of line segment WX and divide it by the measure of line segment AB. Well, 110 divided by 11 is 10. And it goes this with the other corresponding sides, that they all simplify to 10. All right, let's take a look at the next thing here. From the example above, we can see that corresponding angles are congruent. They are in fact congruent because they're absolutely equal, but the corresponding side ratios are proportional. So they're not the same, but they're all multiplied by the same value. Okay, you'll see that 110 is 10 times what 11 is. And if you multiply 15 by 10, you get 150. If you multiply 4 by 10, you get 40. And if you multiply 8 by 10, you get 80. So all the sides have been multiplied by the same value. The mathematical symbol for proportional is this symbol. So the ratio of side lengths are all proportional. And it doesn't matter whether you have the shorter side on top or the bigger side on top in each fraction. The only thing is you have to have either all the short sides on the bottom or all the short sides on the top. You can't mix and match however you please. So let's determine if each pair of polygons is similar. Now, Miss Moyer said she watched my last video, so I'm going to say hello to Miss Moyer and draw a little smiley face. Sometimes she checks in on how I'm doing on these videos. So let's check to make sure that each pair of polygons is similar. Well, the first thing we can check out is all of these have the 90-degree symbol. So all angles are 90 degrees. Therefore, we can use our little therefore symbol. All angles are congruent. Okay? So now we need to check out whether our sides are congruent. So let's take the longer side of the bigger triangle, and let's create the numerator, and let's take the shorter side and create the denominator. And we're going to do the same thing for the rectangle on the left. We're going to take the longer side and make that our numerator, and the shorter side is our denominator. Oops. Let's back up a little bit here. We need to compare the triangles to each other. So we're going to compare the two long sides, so 50 over 35, and compare that to 16 over 10. Sorry about that. So we're comparing 50 over 35, and we're going to compare 16 over 10. So 50 over 35, that simplifies to 1.428, and 16 over 10 is 1.6. So is 1.428 equal to 1.6? No, it is not equal. Therefore, the rectangles are not similar. So to go over that again, you're wanting to find out, well, what is the value if I go from 35 to 50? And if I multiply 10 by the same value, will I get 16? And in fact, you do not. because to go from 35 to 50, you need to multiply by 1.428, and to go from 10 to 16, you need to multiply by 1.6, and those are not the same value, so they're not similar shapes. Okay, let's check out this next example here. One thing to note, angles in a triangle add up to 180. So for this first one here, we've got 180. We're going to subtract the 70 that we know, and we're also going to subtract the 90 degrees, which we can tell from that symbol there. So the missing angle is going to be 20 degrees. And on the left here, we can do the same argument, 180 degrees minus 90 degrees. And subtracting the 20 degrees is going to leave us with 70 degrees. So if we check all our angles, the corresponding angles are in fact congruent. Now we need to check to see if the corresponding sides are proportional. So you can pick any one to start with. How about we start with the hypotenuse? So 25 over 10. That's going to be our first fraction. And then let's compare 20 over 8. And we're also going to compare 15 over 6. Notice that I have all the sides from the triangle on the right are the numerators, and all the sides from the triangle on the left are the denominators. So check your proportions here. This is going to simplify to 2.5. This is going to simplify to 2.5, and this will also simplify to 2.5. So because that's the same proportion, you can say that, therefore, the corresponding sides are proportional. Therefore, the triangles are similar. Another way you could say this is draw the little triangle symbol, and as long as we're doing it in the same order here, so we're going to go A, Y, P. So we're going to go from the 20 degree angle to the 90 degree angle to the 70 degree angle, and you can say not congruent, sorry, is similar to triangle BOX. Okay, this one's a little different. The statement says that the two pentagons are similar, so we know that they have the same proportions. Or you can use the same proportional reasoning to figure out the missing sides. So we need to look through and figure out, first of all, what is our proportion here. So calculate the side length of FJ. So we're wanting to figure out FJ, which is that unknown there. So let's call that X. So starting with your variable, X over, now let's find the corresponding side. So that's going to go with 8. And now we need to compare it with two sides that we know. So let's pick GF, and that's going to go with BA. And both of those have values that are already written there. So GF is 1, and BA is 4. Okay. Now, doing what we did yesterday, you can figure out that X is 2. So that missing side length here is 2. Now we need to figure out the side length of BC. So BC, I'm just going to erase some of this stuff so it's a little bit clearer. BC is this part here. So that goes with that side length on the smaller shape. So Starting with the unknown, let's call it something else. Let's call it y. So y is the variable we're looking for, and we're going to put that over 1.4 because that's the same side. And let's compare it again to that same two sides that we know. But in this case, it's going to be 4 over 1. And that's because the triangle on the left, sorry, not the triangle, the left shape values is on the numerator, and the right shape values are the denominator values in this case. So if you go ahead and solve, you will find that y equals 5.6 centimeters. Okay. One more example where we're given that they are indeed similar. So you don't need to prove or find out if they are similar. We're told that they are similar. So we can then compare sides. So calculate the length of GH. So GH is this one here, and it's our unknown. So we're comparing that to PQ. So starting with HG over PQ, and we need to compare that to some other values. Now the ones we're given are 5.4 and 8.1. So it's going to be 5.4 over 8.1. And if you solve this, you will get 21.6 centimeters. And calculating the value of NP, okay, let's just erase some of this stuff here. NP is over here, so we're comparing that to FG. So NP is our unknown, let's call it Y. So Y over 27 is going to be equal to 8.1 over 5.4. And if you solve, you're going to get Y equals 40.5 meters. Okay, we are going to do some more solving with algebraic expressions. So instead of just one value, you might see something like x minus 2. Okay, you still need to use that whole x minus 2 in your proportion, not just x or not just negative 2. Okay, this is an entire term here, x minus 2. So given the following pairs of polygons are similar, solve for the value of x. So we're going to start with x minus 2, and the corresponding side on the shape on the right is 12. And then compare that to some known values. So you could use 18 and 24. And solving for this, what we did yesterday is you would multiply each side by 12 and 24. 12 would simplify, the 24 would simplify, and eventually you are going to get that x is equal to 11. I won't go through how to solve step by step these algebraic things because that's what we did yesterday. Okay, so solve for the value of x here. This is our unknown, so we're going to start with the unknown side over its corresponding side, so 63, and compare that to 42 over 49. X minus 2 is its own term, so you're going to multiply each side by 63 and 49. Again, you'll see that the 63s will simplify and the 49 will simplify. Then if you use distributive property, you'll eventually get an algebraic expression, and then you'll go on to solve it, and you're going to get x equals 7. Okay, this one's a little bit different because the two triangles are actually enclosed in one one another. So there's the smaller triangle, and there's the bigger triangle. So you could actually separate these two triangles like this, and you'll get KGH with a side length of 6, and you'll get KJL, and the side length is 10. GH is X, and JL is 15. So you want to figure out what X is, so start with X over its corresponding side of 15, and compare that to 6 over 10. And eventually this will solve X equals 9. And one more example here. Again, the two triangles are kind of enclosed in one another, so you can separate the two triangles. Just redraw them. PVW with a side length of 9 and X. And then you've also got P, Q, and R. Now, how do we figure out this entire side length here? Well, this part's 9, and this part's 9, so the entire thing must be 18. Okay, and then the hypotenuse on this side, well, I'm assuming it's hypotenuse, is 22. So let's go ahead and solve for the unknown side. So we're going to start with X over its corresponding side of 22 and compare that to 9 over 18. And if you solve, you'll get X equals 11. All right, we do have a couple more examples here. Enclosed triangles. So we've got this one, which has a base of 12, and this is 9. And then we also have the bigger one, which has a side length of X. And we need to figure out this entire length here. So it's going to be 12 plus X minus 8, which will simplify to X plus 4. Okie dokie. How do we figure this one out? Well, we'll start with the unknown. X over its corresponding side of 9, and compare that to X plus 4 over 12. Now this one I actually will solve. So we're going to multiply this side by 9 and by 12, and we're going to multiply this side by 9 and by 12. That simplifies, and you're going to be left with 12x. The 12 simplify to 1, so you're going to be left with 9 multiplied by x plus 4. Use the distributive property, and we get 9x plus 36. Subtract 9x from either side. 3x equals 36, and x equals 12 if you divide by 3. Perfect. So this side is 12, and this side would be 16, because 12 plus 4 is 16. Okay, last example here. We want to figure out what the value of x is. So we have two triangles. I'm going to redraw them. We have the smaller triangle, and this side length is 7.5, and we could label this as ABC. Okay, and we know that they're similar because this angle is equal to this angle. This angle is 90, that angle is 90, and angle A is actually the same as itself, angle A. So we got the smaller one, and we got the bigger one. The side length is x. The base of this is 3 from there, and the entire length here, you got to add 7.5 plus x plus 1.5, which you actually get x plus 9. So let's solve this. X from here over its corresponding side of 3 is equal to x plus 9 over 7.5. If you multiply each side by 3 and by 7.5, you'll get 7.5x is equal to 3 multiplied by x plus 9. Using the distributive property, (3x) and 27, and you'll eventually get 27 is equal to 4.5x, and oops, I got that on the wrong side. 4.5x equals 27, and x will equal 6. So this is 6, and this must be 15. And that's it for lesson 2.